Hello, on this video I'm going to talk about recursion. Alright, so let's take a look at some code for that. But before it starts, I just want to mention that I am not a big fan of recursion, and I only use it when I absolutely have no other solution for that. And there's a couple of reasons why I feel this way. It's because it feels for me that's going to use more resources on your computer, and also I have developed code in other languages, and it feels for me that Python is a language that you don't need recursion. However, I'm going to show you how recursion works, just in case if you ever need to use it. So recursion is when you have a function and the function calls itself. Now there's a couple of problems there. Is one, you can have an infinite loop. And just in case if you have an infinite loop, just use Ctrl+C to quit the program. So on the recursion, the program can run out of memory really quick. So let's write some code now. And I want to write a code to calculate factorial. Factorial is the product of all positive integers less or equal than the number that you're calculating. For example, the factorial for 3 would be multiplication of 3, 2, and 1, which is equal to 6. The factorial of 4 is a multiplication of 4, 3, 2, 1, and so on and so on. So this is how factorial is calculated. But now I'm going to write a function that calculates the factorial for me. So here I'm going to define a factorial function. And this factorial function returns 1 if the number is equal to 0. That's because the factorial of 0 is equals 1. If it's not, then it returns the number multiplied by whatever the function calls itself. So in this case here, this function is calling itself. However, it's passing the number minus 1. So this number here would be equivalent to returning the 3. And then this number here would be equivalent to returning the 2. And then on the next loop, it decreases one more number again, and then returns the 1, and so on. So this here will just calculate the factorial for me. So I'm going to call this function now, and I'm going to pass the number 3 as parameter. So factorial of 3 should give me 6. I'm going to run this program now, and it gives me 6. And if I pass this with number 5, should give me 120. Yep, I get 120. All right, so this is how the recursion works. And you can solve a lot of other problems. You can reverse strings and you can do whatever you want to do. But basically, recursion is good for when you have a problem and you can divide the problem in small pieces, and you can use those small pieces to call the function again. All right, so this is a happy path right here. So let's take a look at some other code where the recursion is bad. So I'm going to delete this code for now, and then I'm going to create a code here, and this code is going to be of a infinite loop. So in this case here, I created a function, and then I just print something. It doesn't matter what I print, and then I call the function again. So the problem here is that there is no way for this recursion call to ever end. So this is going to call itself, and then comes back here, calls itself again, and it keeps on calling itself again forever. There's no ending point. And now I'm going to call this function, and then I'm going to run this program, and you're going to see that soon we're going to have an error. So the code is running, and then suddenly I have an error right here. It says max recursion depth exceeds, and then I have a recursion error. All right, so let's take a look on another problem right here. I want to create a function, and I want to make the program to use a large amount of memory. And then I'm going to call this function. My string, I'm going to pass letter A. I can pass anything here. This function right here is going to receive a number, and I'm just passing a number here because I want to see how many iterations this function goes through. So I just increase the iteration by 1 every time the function gets called. Then I'm printing the date and time here. I just want to see what change I'm having. But here is where every time you call the function, I'm copying the string on itself twice. So every time I call this function, the size of the string doubles. And then finally I call the function itself, and I pass the string, which is now double in size, and I pass the I here just for me to count. So I'm gonna run this program. Oh, date and time is not defined. I need to import date and time. I'm gonna run again. So you run very quickly on the beginning. Now, or on iteration 31, 32 is running very slowly. And it's running slowly because now it's using a bunch of memory. So I'm gonna open my task manager here on my computer, and here I see how much memory it's using. So it's using a very, very large amount of memory here. So the computer that I'm using right now only has 8 gigabytes of memory, and it's full. So I'm gonna stop this program and then I'm gonna run again, just so we can see the memory dropping and the memory spiking again. So I'm gonna close this. I'm gonna kill it. And here you can see that the memory usage dropped a lot. Now I'm gonna go back to my code and I'm gonna run this guy again. And then here you can see the memory usage spiking up again all the way to the top. So that means I run out of memory on only 33 iterations, 32, 33 iterations. So anyway, any other program now that's running on this computer is going to struggle a lot because this function is using a lot of memory. All right, so finally, if I look at my code again, I have here a memory error after 34 iterations only. So back to the code again, the whole point that I wanted to show you here is that recursions work. They can definitely help you, but they definitely have the downsides. And I truly believe that on Python, you should try to avoid recursion as much as possible. Only use if you do not have any other option. All right, so that's all for this video. Thanks for watching.